Hello and good morning. CTS267, Section 840 students for the spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this morning's video tutorial and solution set is going to be for challenge activity number 17, where we're going to be taking our first look at the Radulko, and hopefully I'm saying that right, Radulko Transport Ltd. Network here. And as you can see, the networking scenarios have gone from, or I should say topologies have gone from rather straightforward to extremely complex. Rest assured, I can almost guarantee there's going to be some BGP action here with two ISPs. We've got I guess, what is this, a distribution center over here or something like that, and then a branch. So we've got a lot of things going on. So let's jump into the first set of tickets here for Radulko, and let's see what we've got going on. So we still work for Sechnik, and the customer had a layer 2 loop in their network. The problem was isolated to switch 3. So here we get a really nice clue as to what the issue might be, and it says, and disconnected the offending cabling. So apparently an employee wanted to have more ports at his desk. I've actually seen this happen before. So he hooked up a small, probably unmanaged switch. Maybe that switch didn't speak the spanning tree protocol, and hooked it into switch 3, and so the cables had been removed. So this should be some pretty low-hanging fruit. This should be pretty straightforward here. Let's get on to switch 3 and let's take a look. So here we are on switch 3. Let's go from user exec to privilege exec and put in the password of Cisco. And let's go ahead and say show run. So we're looking at the different ports and how they're configured here. So we see right away the Ethernet 0 ports, 0, 0, 0, 0, 1, 2, and 3. So these are properly configured for a host-facing port. And I say properly configured because we've got port fast edge, right, which means we're going to skip the listening and learning states. We're going to go straight to the forwarding state when we plug the port in. And then we have BPDU guard enable. Now, what we're doing here, you can see that we're doing this on a per port basis. Now, you can do this per port. You could also do it globally. If I was to do it globally, I would say spanning tree, spanning tree port fast enable, and then spanning tree port fast BPDU guard enable would be the commands that you would run from global config mode if you didn't want to do it on a per port basis. But these are both best practices for, and that's supposed to be a B, and that is supposed to be a P. These are both best practices for host-facing ports, because if it's a host-facing port, we don't want it to have to wait to go through the different states. Even in rapid spanning tree, we want it to go to the forwarding state immediately. And the same is true of the BPDU guard enable command, is that we don't want end users plugging switches into host-facing ports. So BPDU guard enable, by default, if it receives a BPDU on this port, it is going to shut the port down, and that is obviously going to get your attention if you see a port go offline on your switch. Now let's cruise down a little further, and it said the offending cabling had been removed. And so it could be 1, 2 or 1, 3. Nope, it's not. Okay, so here's the problem. Okay, so this should be pretty clear, and this is a conversation that we had during the switch course. So we take a look at Ethernet, so I guess the 2, 20, 21, 22, 23, and then we go to the 3. We'll see what's on 3. But you can clearly see we're going to have an issue here. So port fast edge, right? You're thinking, yeah, you just told me that that was the best practice. It is. And so is BPDU guard. These are both best practices for host-facing ports. However, that command right there, spanning tree BPDU filter enable, this basically disables spanning tree protocol on the port on which it's configured. And if you're looking at this thinking to yourself, well, wait a second, didn't you also just tell us that BPDU guard, if it receives a BPDU, will shut the port down? And so here's one of these lovely Cisco semantics, is that if on a port you enable both BPDU filter and BPDU guard, BPDU filter is what gets enabled. In other words, the port will ignore the BPDU guard command and defer to the BPDU filter command, and BPDU filter turns spanning tree off. So in other words, if the scenario that we ran into with the Cisco switch, and then we'll say the employee switch, was that the employee went like this and hooked two connections in, and BPDU filter was on here, and this switch doesn't do spanning tree, we've just created a loop into whichever VLAN we've plugged those ports into. And so we're going to assume here that it was VLAN 10. We'll see maybe these ports here, 30, 1, 2, and 3. Maybe they've got some other VLAN assignments. We'll check that out. But initially, right now, we can see that this is a problem. Here's BPDU filter again, and here, right? So that's one of the issues, at least on these sets of ports. If I was to scroll further down, okay, so these are shut down, and that's what should happen, right? If the ports aren't in use, if we don't have something plugged into the port, it should be shut down. So we've got Ethernet 4142. Well, we got quite a few ports on this switch here. So these ports here, 51, 52, 53, 50, those should all be shut down. So BPDU filter is not enabled on those. So it's got to be, the issue has to be with the 20 through 23. Although, let's get into global config interface range, Ethernet 50 to 3, and we want to shut all those down, right? Because they're not being used. This just says switch port mode access. So it doesn't appear that they're being used for anything. And 4.1, those are all shut down, so we're good there. Then we want to say interface range 20 to 3, and Ethernet 20 to 3. And we want to say no spanning tree BPDU filter enable. So now let's say do show run, and let's begin at 20. So now we should only have BPDU guard and port fast edge enabled on these ports. And again, from global config, we could have said spanning tree port fast edge in default, not enable. So spanning tree port fast edge default, we could have said that, and that would have applied to all of the ports. But then on top of that, what we want to say is spanning tree port fast BPDU guard, and did I not get that right? Hold on. And then one edge, and then BPDU guard, because we've got rapid spanning tree running here, and default. And so that would turn it on all of the switch ports that we're going to end up using as access ports, right? So that takes care of the first problem. The second one looked a little involved here. This is a pretty large area here, or a pretty large paragraph. Okay, we've got a firewall installed. However, so the distribution center, and that's that DST router. Okay, as a result, Marjorie configured, and so again, we get a very nice clue here, was that Marjorie has configured policy-based routing on the DST router. So right now, without even reading any further, we can make a pretty good assumption that it's going to be something to do with the policy-based routing. We can also make another assumption. If we understand how policy-based routing works, right, there's going to be an ACL involved, right, because it's probably matching the destination IP address range. And there's a route map involved. There's also the IP policy command that's going to be involved. So my guess is we're dealing with something that's wrong there, so we're going to have to hunt down the policy-based routing. So all PC traffic destined for the internet goes through the headquarters. All server traffic destined for the internet goes directly to the internet. It says everything works except now PCA cannot access the local server SRV. So fix this without breaking the existing policy. So it sounds like everything is working. So this is hinting more towards something wrong with the ACL. And maybe we're matching, again, because PBR is destination-based routing, right? If we think back to the route course, and let me pull the job aids up here and see if they should have some sort of a diagram. So there's the diagram I'm looking for. Here's the BGP information. And so, yeah, we've definitely got 2 BGP ASs. Okay, and here's the PBR, and I think, okay, so here we are, right? So now this is where it's going to get interesting. So let's think back to how policy-based routing actually functions. So it's on the DST router where the PBR is applied. We saw from that other image higher up that this is where the PBR is going to be applied. So if the goal is to get all of the server traffic to immediately transition to the internet, the server traffic would come up here. My guess is this is going to be a router on a stick. It's going to come into whatever incap.1q, whatever VLAN interface this is for, and it's, again, matching based off of the destination. It would come out here, and it's going to shoot out to the internet. Now, we can see the server VLAN is VLAN 2 on this switch. So it would be incap.1q2 is my guess is the interface here on the DST router. And it's that PCA is trying to talk to the server. So PCA's traffic is coming through the switch to the router, right? And this is how we're doing the inter-VLAN routing. If this was a layer 3 switch, we could do it right here off the switch, but it's definitely probably just a layer 2 switch. But this is our layer 3 device. So my traffic from PCA in VLAN 10 is coming down this way into the router, and it's going to, or trying to go to, the server, right? And it's saying that that is broke. And so, again, the assumption here is that traffic from the PC is probably working, but traffic from the server coming back is going to be wrapping this way. But remember, policy-based routing is all about destination-based routing. So when we think back to how PBR is supposed to work, or how, let's talk about regular routing, right? So a packet shows up here. Let's say we've got an interface here. When I should say a frame. When the frame shows up on this interface, right, we take a look at that layer 2 header, which is going to be the source and destination MAC addresses. HQ1 examines that and says, hey, yeah, this destination MAC address, that's me. So this is definitely destined for me. It then discards the layer 2 header and then opens up the layer 3 header information, and it looks at source and destination, and specifically the destination-based information, because that's where the router, in looking at that destination-based information, is going to make its routing decision. And it's going to say, what destination network am I trying to go to? Right? So is it going to go out that interface? Is it going to go out this interface? And it's all based off the routing table, and that's where Ceph comes into play. When we talk about PBR, we're talking about source-based routing. So PBR is overriding the default layer 3 lookup by using an ACL and a route map in order to set the next hop. And in this case, and if I were to clear this off, in this case, when the server traffic generated by the server comes up here into this router, right? As soon as that hits this interface, we have an IP policy statement here, right? We're going to have an IP policy statement referring to the route map. And that IP policy statement is going to be put into play. And we're going to try to match the source network. If that network's being matched, then we go into the route map and we would set the next hop. So the way that this will be set up when we take a look at DST, I guarantee that the config is going to be matching the 10.1. Or the ACL is matching that source network. And if I said destination earlier on, I apologize. So PBR, again, PBR is all about source-based routing, which is the opposite of destination-based routing, which is the default, how routers typically route. So source-based routing, there's going to be an ACL that matches that network. There's going to be a route map that then has a statement that says match IP address and then whatever the ACL number is, or name if it was named. And then it's going to say set IP next hop for internet, right? For this traffic. The problem is that when the server tries to get to PCA, that same traffic that we would expect to come into the router and then go over here and route out to PCA, it's probably not going to happen. It's going to get caught by this ACL. And this ACL, because my guess is they're probably just matching the whole /24 and there's nothing in there to say, yeah, well, if it's going to PCA or if it's going to PCB, right? These PCs in 10.1.10 0/24, not to match that traffic, right? We're probably matching everything. So let's dive in and let's take a look. But we needed to talk about how PBR works, how normal routing works, and then how PBR overrides that. So we need to get onto the destination router, which, of course, we do not have console access to. So, and this is nice here. Okay, so SSH, not Telnet, SSH from the HQ to 10.1.2.1. So we'll go from HQ2 here. So we're on HQ2. Let's get into privilege exec and C1SC0 and SSH -L admin to the 10.1.2.1. And that was the correct IP. Or was that the correct? Oh, okay, well, that took a while there. All right, so let's get the password in. And there we are. We're on the distribution router. So if I was to say show IP policy, that's the first command we're going to run right out of the gate. That is going to show us what interfaces or on which interfaces do we have PBR applied. So just taking a look at this right out of the gate, and I apologize, we switched routers there. There we go. We don't get a ton of information, but we get enough to get us going. We can see that it's definitely a router on a stick because there's the sub interface, Ethernet 00, which then goes into a trunk port on that switch. And that is the name of the route map. So from this, I know that we've got policy-based routing. I know that it's applied here to that sub interface, and I know that that's the name of the route map. So from this point, right, I can back myself into, all right, well, if I know the name of the route map, I could say show, actually just show route map, sorry, show route map srv-inet-rm if we only wanted to see things for that route map. And so here we are, and we take a look at this output, and that's the route map name. We've got a permit statement as sequence 10, and there it is. What are we matching? IP address, access list, and the name of the ACL is srv-inet. And so whatever we match in that ACL, we are going to set the next hop to 209.165.201.2. Again, overriding the normal layer 3 routing process and order of precedence that takes place in a router. So anything that we match in this ACL, and so now we're going further down the rabbit hole, getting closer and closer to what exactly it is that this ACL is matching. So let's take a look at that. And here we are on the destination, the distribution router. So now I'm going to say show access list and srv-inet. So now let's look at that ACL. And so here is what that ACL is matching. And so this is definitely going to be the problem, is that it's matching everything in the 10.1.2.0, and I could put after that a /24. You can see we have our wildcard mask here. So all traffic that shows up with a layer 3 header information with a source in the 10.1.2.0/24 subnet, which is that server subnet, if that IP packet shows up to the distribution router, and the source IP in that packet header is 10.1.2 whatever, from 10.1.2.1 to 10.1.2.254, right? And 10.1.2.1 is probably the address on the sub interface, wherever that sub interface there. So, but whatever assignable IPs in that subnet, if they are in the source header field in the IP packet, the next hop is immediately changed to 209.165.201.2. No ifs, ands, or buts, right? So traffic trying to get back to, or trying to go to PCA or to anything, to anywhere from this server, if that's your source IP, it's not going to work. And so now I'm going to pause here for a second. So now we need to sort this out. And obviously we're using an extended ACL here, which is extremely convenient because we're going to, well, we don't want to change that. We can't change the any because we've got to make sure that it continues to work. So what we're going to do is we are going to insert a sequence number before 10 where we deny, where we don't want it to match the traffic. So the any is going to turn into the subnet. I can't remember what it was. I think, was it 10.1.10.0/24? So the any, we're going to put in a new sequence number, and we're going to not match, or not, what we're basically saying is we don't want a policy-based route traffic that comes in with a source of 10.1.2.0 that is destined to the 10.1.10.0. Again, that PC subnet. So this is actually not too complicated, and let's see if that is going to resolve the issue here. So I need to double check that where was that picture at here? Yeah, so the PC's 10.1.10.0/24. So we want to make sure that, and we'll talk through it as we enter it in, is that traffic is not going to get matched. So we're going to go into global config, and we're going to say IP address, not IP address, IP access list extended. Boy, there's a lot of lag here. IP access list extended, and the name is SRV-INET. And so what we want to do here is we want to say 5, right? Because remember, there's an implicit deny any at the end. The problem is this is catching everything coming off the 10.1.2. Going anywhere is going to be policy-based routing. And so what we want to say here is deny IP traffic from 10.1.2.0.0.0.255. So anything originating from the 10.1.2.0 destined not to anywhere, but destined to the 10.1.10.0, 0.0. Boy, it's taking forever there. .255. Sorry, I'm pausing because I'm waiting for it to type it out here so that I don't have to go back and fix any typos. So that's what we're going to do. So any traffic that policy-based routing route map is going to try to policy-based route is not going to policy-based route when the source is 10.1.2.0/24 destined to the 10.1.10.0/24. And let's hit enter. So now let's go ahead and take a look here at do show IP access list SRV-INET. And so there we go. So basically what we did, we just inserted an ACL line with a lower sequence number that's going to deny things first. So that should allow the traffic, because we're not matching on traffic going to 10.1.10. That's what that deny statement means. It says don't match in the context of the route map that's referencing this ACL don't match that traffic. And so let's see what that is going to look like. And now we are faced with the task of getting to the server. So let's, what was the server IP? And I apologize, these IPs, they change. And it's for, let's back up here, hold on. Server, SRV, okay, there we go. So we can SSH from the headquarters to 10.1.2.10. So let's go from HQ1. Let's get into privilege exec. SSH -L admin to 10.1.2.10. So let's get to the server. And actually, this will be very easy. And before we do that, let me take a look here. Do show run interface Ethernet 00.2. Did we already look at this? Let's make sure that the statement's on here. So everything else was working, so that statement should have been there, but I just want to double check. So there's our IP policy route map statement. This is what's doing the policy-based routing on that sub interface, right? So hopefully we are going to get a connection here, and there is an extreme lag. And was that the right IP, or was it 10.2.1.10? Let me double check that IP. Server 10.1.2.10, and we should be able to SSH from headquarters. Okay, let's get off the distribution route, or let's get off the distribution router. Let's try it from, maybe it's HQ2 we've got to do it from. -L admin 10.1.2.10. That's definitely the IP. Is the user, while that's thinking, let me double check the user. Yeah, admin Cisco. So we should get a prompt here to log in, and this has taken a little longer than anticipated. All right, we'll give it a few seconds here, and hopefully this does not time out on us, because we want to make sure that we can show that it's not policy-based routing the traffic out to... And you know what? I'm wondering if the PBR statement is causing us to not be able to get over there. It should not be causing a problem. So can we get on to maybe PCA or PCB? All right, let's see if we can get on to either of those PCs. SSH from headquarters. So it's using DHCP, so we don't know the address of PCA, or so we've got to get back. So let's do this. Let's get back onto the destination router here, and let's see if we can figure out the IP address for either of those PCs, which are causing some issues here. All right, CISC0. All right, so let's say show IP ARP. And it's going to be in the 10.1. Yeah, so that's probably our Ethernet interface. And then here we go. So it's got to be .11 and .12. So let's try from HQ1. SSH -L admin to 10.1.10.11. Let's see if we can get onto PCA here, because we're not having any luck with the server. Okay, there we go. Much better. All right, so here we are on PCB. So what happens when I try to ping over to 10.1.2. Was it 10? All right, we've got full connectivity. What if I try to trace? And again, these guys are both in. Let's trace over to 10.1.2.10, and that's the server. And while that's going, let me make sure 10.1.2.10. I'm going to make sure I'm tracing to the right IP address here. The server. Yeah, 10.1.2.10. Okay, so we've got connectivity. That's working. And I should have done numeric. You can see we go 10.1.10.1. So again, that's the interface on the router, the sub-interface on the router, with the incap.1q10 for VLAN 10 traffic, and then we make it over there. So what I should have done initially, sort of assuming that that was the problem, let's get into global config and let's say IP access list srv-inet no 5 access list extended. I always forget the extended keyword. So let's get extended in here, and boy, the lag is terrible on this. And we're going to say no 5. And we know what 5 is, right? 5 is the statement we put in earlier. So now let's confirm that it would have been an issue if I try to do a trace over here on PCB, and we'll do it numerically this time. It doesn't like that. Okay, right. Thinks it's a PC, so let's just go with the ping. 10.1.2.10. So do I have any connectivity? I don't. So in fact, yeah. So this was a problem. We could see it was a problem, though, from the ACL. But again, let's confirm the problem. And then we know our solution to the problem was to come back and say, and we'll put this in again. And so we know that the solution to the problem was going to be to say, what do we do? 5, deny IP from 10.1.2.0.0.0.255 to the 110.0.0.0.255. Okay, there we go. So that should sort it out. So I should be able to come back to PCB, and that ping command, not the trace, but the ping. Whoops, sorry about that. There's just a big lag here. And the ping should work. So there we go. So we've sorted it out, right? So we don't want a policy-based route traffic that's coming to the local subnet. So that sorts out issue number 2. Let's take a look at issue number 3, which looked pretty simple. We have literally a sentence. Notice even though switch 2 is connected to switch 3, that CDP is enabled on both devices, they do not recognize each other as neighbors. Is this a bug? See if you can fix it. So switch 2 and switch. So we'll check with switch 3 first. We're already on switch 3. So let's get into privilege exec here, SCO, and let's say show CDP. So CDP sending packets. So CDP is enabled. Show CDP neighbor. I see switch 1, but not switch 2. So is CDP enabled on switch 2? Come over here, SCO, and show CDP. And it is enabled on switch 2. And let's take a look and see. So yeah, we definitely have traffic going back and forth. And let's see if they disabled it. So if I were to say show run include CDP, no CDP. And actually, let me come back over to switch 3. Show run include, whoops. Let's say show run include CDP. Yeah, no CDP. That's what I thought it was. No CDP enable. So the problem is going to be here. And what is that interface? Let's say show run. I'm not sure which interface goes between the two. But we're looking for the interface that's going to have no CDP. And it's got to be this one right here. So you can enable CDP, right, globally. You can disable it globally, but you can also disable it on a per interface basis. So if we went into Ethernet interface 1.1 and I said CDP enable, now when I say do show CDP neighbors, we should see, and maybe it's disabled on the other side as well, do show run interface Ethernet 1.1. All right, so I should see more than switch 1. We should see switch 2. Let's shut this interface down. And then we're going to bring it back up here in the hopes that this may resolve the issue. Do show CDP neighbor? No, so switch 2. Let's check here. Show run. Is it disabled here? On no, so it looks like it's not disabled anywhere. Let's say CDP run? Yeah. And is it over here? Is it running over here? It should be running over here by default. CDP run interface Ethernet 1.1. do show run interface Ethernet 1.1. CDP enable. This should be working. And again, it's the default, which is why we don't see it here. Do show CDP. And maybe we just have to wait. There we go. Maybe I didn't wait long enough for those CDP packets to be sent back and forth. But again, yeah, it was because CDP was not running. It was shut down specifically on the Switch 3 interface. All right. Well, this is going to wrap up challenge activity number 17, our first look into the Radulko network. All right. Well, thanks so much for watching, and I hope to see you in the next video.